Alright. Attention, please. So we're gonna do. We've done two things with like area between curves. The first thing we did was find like the area between this curve. That was just like top on its bottom, and then we've been spinning it around an axis. Right? So this new thing is if the base is the cross section. If the cross section of the shape is the base of the shape. This is why I have this thing up. We're gonna find the volume of cross sections. GeoGebra. So a cross section is one of those. All right. Can we just like wipe the last 50 seconds and start over? I got this. Okay. This is a two-dimensional graph until I do this. Now it's a three-dimensional graph. That's what a cross section is. The cross section is just the distance between like one base and the other base. So this is the same as we've been doing. What's the distance from this equation up here to this equation down there? Top and spot. So what's the area of this? This is a square. What's the area of this one square? Top minus bottom times top minus bottom, right? So if you were able to add up a bunch of rectangles, you get like this three-dimensional figure. And if you add up infinite rectangles, we're going to find the area of that. Ooh, upside down. Because it's a square, so however wide it is also that tall. Get rid of the x. So that's like just showing you what the cross section looks like at different parts of the graph. So I can kind of move it over. They can be semicircles. So there's like that's the cross section, like a two-dimensional shape, and then that cross section. Oh, that's cool. I didn't know it could do that. Alright. So the cross section turns into a semicircle. It could be, stop talking please. It could be an equilateral triangle. And then if I fill it up, you can kind of see the shape that we fill in there. Kind of. Yeah. So that's what we're going to be trying to find. We are going to kind of try to draw them, but it's hard. But we can find the value of them. Okay. So we have a couple things going on here. Go to the back. Like below the answers, we just write down a couple notes. The first first thing we should do is write down some area formulas because some of you guys don't remember them. What is the area of a rectangle? Base times height. Because it's solid. A square. Base times base, but the thing's probably easier to write as base squared. A semicircle given the diameter. So it's probably r squared over 2, right? But what's r? It's d over 2. And then if it's a semicircle, what else would it be? Would you agree with me that this is the same thing as 1/8 pi d squared? Well, then you're wrong. Squaring the 2 on the bottom here would give you what? 4, and then you have 2 on there. So that's where I'm getting 8 from. Oh my god. The pi just stays. You don't have to count. Alright. A rectangle with the height triple the base. Area of that. So if the base, we call the base B, and the height is triple, what do we call the height? 3B. So it's like base times height, but the base, or the height is 3 times the base. So couldn't we write it as 3B squared? I think that's all the shapes I put out here. Oh, no, sorry, one more. Isosceles. I don't know how to spell isosceles. Alright. Isosceles right triangle. Where you have. How does it work, you said? It'll look like that. So, what's the area of any triangle right there? 1/2 base times height, but if that's isosceles, isn't it 1/2 b squared? Agree? Yeah, b squared over 2, that's fine. Volume is just the integral of area. Integral, I just can't write. But it says you already knew that, right? Yeah. This is light work. Right. Are we good on the back page? Alright, so let's look at the front. If I were to do number 1, the first thing I always do is start off with the, like, forget volume even exists. And I want to find the area first. So I have rectangles. With heights twice that of the side in the xy plane. So the side in the xy plane is this. And we're making rectangles where the height is 2 times as large as that. As the base is the distance between the 2 curves. And the height is 2 times bigger than that. So I'm trying to draw it. Not like ideal at this. Do we have to draw it? You do not have to draw it, but I'm just trying to get you to understand like what it looks like. Oh, it's not like to scale. Oh yeah. I'm just trying to draw the shape. Okay. Yeah. So what's the area of a rectangle whose heights are twice that of the side? Well, a rectangle is base times height, right? And if the height is twice the base,
I'm just kidding.
Do you see what I'm doing here? And then I would rewrite that as 2b squared. Right? So my job is then to integrate 2b squared from -3 to 3. Well, the base is how large? What's the size of the base? What's the distance between these two things? Top minus bottom. So the base becomes top minus bottom. Or like the side of a triangle is top minus bottom. Or the diameter is top minus bottom. Like whatever this distance is plugs into your area formula. So we're gonna say -3 to 3 of 2 times the top minus bottom squared. So the top equation is this guy. The bottom equation is just here. So top minus bottom is just going to be -x squared over 9 plus 1 and then squared. And you can type that in and get an answer. I'm not going to worry about that. Why isn't there pi out here? Because all the volume ones we did before had pi out here. It's squared. When we were revolving, we're making circles, right? If we're making circles, you're going to have a pi there. If you have a semicircle, it's going to have a pi. But otherwise, you're just looking at what's the area formula. Then you want to integrate it, but whatever variable's there, whether it's radius or height or whatever, you replace it with top minus bottom. Because that's the distance between the two graphs, which represents like the base of the shape that is sticking out. Does that make some sense? A little. Other questions I can answer usually.
So you don't care about the answer, you just want the formula.
No, I want you to care about the answer. I just don't want to take time out of the lecture. Like, okay, everybody type it in. Because I'm pretty confident you can all do that. You know what I'm saying?
I can clear the screen.
F1. It's like the 5th time you asked this. I've got to memorize now. Wait, you're making me smart. You're improving my skills.
That's this guy.
Okay. Number 2 here. It's a little bit trickier. Again, I have rectangles. Again, they are twice the height. So again, I get 2b squared. Agree?
Yes.
So what I've got is any rectangle in here. I'm going to make this a scalar.
Yes. Yes, please.
But it's like angles, so it doesn't quite.
No.
No, just
These are
something like that.
perfect.
You get these little shapes coming out. That's pretty good.
Stuck in the thing. Yeah. And it's solid.
Stuck in the thing. Are you talking about my drawing? Alright, so I'm going to integrate. Again, from -3 to 3. It's not that every time. It just happens to be in these two. And I'm going to integrate 2b squared times the x. We got a little problem here. Comes on you, I suppose. I only have one equation. So how do I do it top and bottom? The bottom is not 0. 0 is the x-axis. Yeah. You could. I think it's easier to do what I'm going to show you, but that would work. Any thoughts? Could I make that into 2 equations?
Yeah.
Alright, let's do that. Let's try that. X squared plus y squared equals 9. If I solve that for y, won't I end up having to take a square root? If I take a square root, isn't there really like a plus and a minus? So that's going to be your 2 equations. So like subtract x squared from both sides. And then square root both sides, and you get plus or minus the square root of 9x squared. So this one on top is And then this half circle on the bottom is negative the square root of 9 minus x squared. Does that make sense? I'm just splitting one circle equation into two equations so I can get the top and the bottom. Alright. So then the square root of 9 minus x squared goes here, and the negative square root of 9 minus x squared goes there. Then you can type it in. I do want you to get the answer again. I just don't want to I don't think it's the most efficient use of lecture time. Kenzie, you alright? You got people's heads in your way? You're actually stretching out. I'm trying to block everybody. Question on 2 there? Where'd you get this from? Why are you doing this? What the hell? Oh, check the language. Those are both rectangles. Let me try to find one that's not.
Here's a square on number 4. Semicircle on number 6.
Let's do number 4. 4's got its own issues. Cross sections perpendicular to the x-axis are squares. So whatever this side length is, you're like coming out of the page that much. You'll have these squares that are kind of poking out. And you have an infinite number of them, so it'll be a solid shape, and you can find them out. So what's the area of a square? B squared. We want to integrate. This time it's from negative 4 to 4. The base square. So I've got a problem again. I only got one equation. Because what I need is two equations, so I can say top minus bottom squared. Yes. So can I get two equations out of that one? Probably. Seems like a good chance I would be saying something. Alright. What are we trying to solve for? Trying to solve for y. I don't want those fractions there. So I'm going to multiply to get rid of them. So basically I'm going to multiply this side. My common denominator is just going to be like 16 times 9. So I'm going to multiply this by 9. And this by 16. Because then won't those bottoms be the same? Plus. And if I multiply this bottom by 9, don't I have to do the top also? If I multiply this, multiply by 16. So now I have 9x squared plus 16y squared over 225 equals 1. Is that 225?
Big number.
144. Sorry.
Whoa.
Not close.
Whoa.
Stay up to watch the basketball game. I can't think.
Yeah. It wasn't fancy.
It wasn't. What would you guys recommend from here? I believe I agree. I multiply both sides by 144, so those cancel. 9x squared plus 16y squared equals 144. Then I'm going to throw the 9x squared over there, so 16y squared equals 144 minus 9x squared. Or what? Each of those like individually by 16. So I get y squared equals 9 minus 9/16 x squared. With me? Yes. This part's okay, yes. Then what do? Root it, so I'm going to run out of room. I'm going to have y equals plus or minus square root of 9 minus 9/16 x squared. So again, you got your top and your bottom. So this piece up here is the the square root of 9 minus 9/16 x squared. And this piece down here is the negative square root of 9 minus 9/16 x squared. So that gives you your top and your bottom. Clearly, really much room here, so you guys picking up what I'm putting down? What'd you say? Let's do. I want to do one more. I want to do a semicircle. Let's do 3. 3 is not a semicircle. What do you want? I want the cross sections to be semicircles. Yeah. There's only one though. You can't do one and then have you practice. Try it. Try 6. Try it right now.
Alright, brother.
So this is the point. One of the points I want to make here. If they say the cross sections are semicircles, what they mean is that distance is the diameter. So it'd be like shapes poking out like this. That's not a good one. The bottom is 0, yeah. Yeah, because they give you this equation and the x-axis. The x-axis is y equals 0. Okay, so am I good to go or no? So what is the area of a semicircle? Keep in mind that distance is the diameter, not the radius. So a semicircle is 1/2 pi r squared, right? This half comes from the fact that it is half a circle. But I don't have the radius, I have the diameter. So then you have to do this 1/2 pi times diameter over 2 squared, which then becomes 1/2 pi times d squared over 4. Right? If I square the top and square the bottom, which then becomes 1/8 pi d squared. So I want to integrate from this one's from -3 to 3. 1/8 pi times the diameter squared. And what's the diameter? It's always top and bottom, right? So your top equation is this guy, and your bottom equation is the x-axis, so it's y equals 0. So it's really just this. You can put the -0 or you could not. And they probably simplified it. They probably have this 1/8 pi on the outside and then like 9 minus x squared in there. Is that the answer? But this is fine. How many have that?
Yes, you
Question
are.
on this. Questions on that? Alright, the rest of the time is for you to finish that up, check them, make sure you're good. Tomorrow what I'm going to do is give you a shape like this, and ask you to find an area, revolve it, cross section, like do a bunch of stuff with one shape. You're kind of reviewing things and practicing, like mix them all up at once. It is a lot easier when today's area, we're just doing area. But when I started mixing things in, you gotta think a little more.
Oh, I wrote the wrong one.
I think it's